Hey everyone. Today I want to talk about AI tracing. Specifically, I want to talk about how you can use AI tracing to diagnose and improve LLM applications. Tracing is the first step in AI evaluation. When you look at traces, you can see how the model thinks because tracing records every step from prompt construction and retrieval calls to generation decisions and outputs. And then you can use that behavior into insights. For example, by reading traces, product managers can pinpoint what is happening with grounding, with retrieval, with prompts, with generation, with performance, all those things. And finally, you can use that insight to improve your application. The ability to read traces and apply your domain knowledge and judgment and taste to manually check the traces of 100 instances of your feature is arguably one of the most important things that you can do. This is something only a product manager with domain knowledge and with a specific understanding of the jobs to be done can do. So that's why it's such an important skill to have for a product manager building AI applications. So when you check the traces of 100 instances of your feature, you will look at it from a point of view of grounding. Is it grounded to the context? Is it retrieving the right pieces of information to send to the LLM? Is the prompt accurate and elaborate enough? Is the generation by the LLM appropriate? Is it not hallucinating or hallucinating? And finally, what is the performance? How much is it costing me? How long is it taking, and so on. So now we are going to look at how we will look at the trace of a particular instance of your feature. If you're building a chatbot, it'll be one conversation between the user and the agent. And then you will look at it from the point of view of these five things. So let's look at this one by one. First, grounding. Is the is the AI agent or the AI feature hallucinating because of missing instruction? So this is literally what you will look at. You will look at the trace, and I will talk about where you can look at this trace in a bit. You look at the trace and say, okay, what was the system prompt? The system prompt said you are a helpful assistant. That's all it said. It didn't give enough context. And the user asked the question, what is the target SLA? And the LLM said the target SLA is 15 minutes, and so on. Where did the LLM get this 15 minutes information from? So, and then you, as a product manager, because you know this context, you will take notes saying, no instruction to use, only provided context was given, and for some reason the context was not sent to the LLM, and because of that, the LLM hallucinated and came up with SLA values that are not present in any documents. So, what is the fix? The fix would be to, first of all, provide a context document, maybe a policy document, and then adding the grounding rule in the system prompt saying answer only from context. If unknown, reply not in the handbook. So, this is exactly how you will read the trace, take notes, and provide or come up with a fix, which you will either execute yourself or hand over to one of your engineering colleagues to execute. Let's look at the next one, retrieval. Um, Retrieval makes sense when you are doing context engineering work. If you are chunking and embedding um, a lot of documents, and then you are retrieving specific chunks to give to the LLM based on the user's query, you will want to check, are the right chunks being given to the LLM? To understand this, you should understand context engineering first. I'm assuming you understand context engineering, so I'm going to say that I'm going to read this and say, okay, the query from the user is what is target SLA. So your retrieval logic should have retrieved appropriate chunks that are relevant to an SLA, and it should have given it to the LLM. But when you glance at it, you realize that this chunk 7, 12, and 2 do not have any SLA related information. So your human judgment, using your human judgment, you can say retrieval missed relevant chunk due to poor embedding match. So because of this, the expected chunk, which should have contained the definition of the SLA, was not retrieved. The fix for this will be to adjust the chunk size. These chunks, these document chunks, are usually between 500 and 2000 words. So maybe you need to adjust that to make sure that the appropriate chunk is retrieved. Now you play around with that. You work with the engineering colleagues to adjust that, and then see if the performance improves. The next one is prompting. If the prompting is ambiguous, the response will be poor. So, for example, if the prompt is as simple as "You are a helpful assistant, answer the user's question," clearly nobody will write a prompt like this. But here it is written on purpose to make my point. And if the user asks, "Explain the escalation process," the model will give a very generic answer. The escalation process involves notifying stakeholders, which is not a useful answer at all. So the notes taken, you will take notes saying, "Hey, this is an ambiguous user prompt. Because of this, the answer is not useful." So what we need to do is we need to very specifically tell in the system prompt, list each escalation stage with responsible team and SLA, and naturally you should give the context documents, the appropriate grounding documents to your AI agent. The fourth one is generation. Output deviates from context. In this case, you probably gave the right context, and yet the LLM responded with an answer which was not consistent with the context information that you provided. Here, if you look at the traces on the left, it said escalation, this particular context was injected. Escalation must proceed through three levels, 1, 2, and 3. But the model said there are typically four levels of escalation. This normally happens when the temperature is very high. That means you can adjust the temperature of the response of the feature. Um, if you keep it very low, that means the LLM will be very conservative. If you keep it very high, the LLM will be creative. So the fix for something like this could be go back and check the temperature of the model, and reduce the temperature, and then also strengthen the system message, the prompt saying do not infer beyond context. Not just adjust the temperature to ensure that the LLM is conservative when it answers this question, but also very specifically say do not infer beyond context. Finally, the performance. Yeah, we have to check for the performance. For every AI capability that you have, you will get answers. You will get very specific information about the runtime, retrieval time, LLM call time, total tokens used, and the estimated cost. So when you look at this information, you can decide what how you should use that information. Are you spending money where it is not required? Or is the LLM spending a lot of time doing things that you really do not value? When you look at this information, you can adjust all that, and improve the latency and reduce costs. Now, finally, these are all conceptual things, and if you're wondering what will what will what will this look like in a real world scenario, so to explain that, I'm taking a very simple application that I built. It's called an iPhone calculator with an AI mode where I can talk to the calculator. And then I have connected this application with Langsmith, which is a platform that will observe your traces, and then it'll give you visibility into your traces, and it'll help you build evaluations, automated evaluations. So let's look at that to see how this feels in the real world for a product manager. None of this requires any programming knowledge. The um, integrating an application with a third-party application like Langsmith or BrainTrust will require making an LLM call. If you're write coding your application, all you have to do is just say add Langsmith tracing to my application. You just write that here, and your vibe coding tool, whether it's Replit or Lovable or any of the tools that you use, should be able to connect your application with Langsmith, which will then start observing your traces, and then it will display the traces here. So let's just look at Langsmith. So for example, um, once you connect, in this case I have connected my calculator app to this to Langsmith, and then it is listing all the traces, and it gives me pretty good visibility into traces so that I can look at them and make my notes about the quality of my features performance. So let's do this live. So I'm going to go to AI mode because I want to look at some traces, and say this is an application that I can talk to. So I'm going to say voice input. What is 25 times 10? No, it's not incomplete or not a mathematical question. Let's try again. What is 25 times 10? All right. So I asked the question, and it transcribed that. It made an AI call for that to transcribe it. And then it also gave me an answer. 25 times 10 is 250. And it also did a couple of other things. It also made some smart suggestions based on my question. It said calculate 25% of the 25% tip on the result, convert the result from dollars to euros, things like that. It made an AI call for that as well. So when I go to Langsmith, I should see the traces of all these AI calls that were made. So here it is. So for example, first I said what is, and then it stopped. So clearly the output should be bad. So I said what is, and then it probably didn't hear me, or I stopped or something, and then the result is obviously not a valid result. It said I don't know, and it still spent some money on it. Now going back to the next one, the next question I asked was, what is 25 times 10? So I said, obviously I said, I talked, I didn't type. So what it did was it made a LLM call to turn my voice into text. And then it obviously got an output saying the expression multiplies 25 by 10, resulting in 250. And this is how many tokens were used. This is how long it took, and how many seconds, and what it cost. And then finally, based on my questions, it also generated some smart suggestions. Because I said 25 times 10, it said, okay, maybe you also want to calculate 25% tip on the result, or convert the results from dollars to users, find the result as a percentage of a larger amount, things like that. I mean, it's probably making the assumption that I'm in a restaurant, I'm trying to calculate a tip, and so on. So this is a like a real world example of how um, an application with AI capabilities will be linked to a tool such as Langsmith or Brain Trust, or the other observability tools in the market, and how you look at the AI traces as a product manager, and then start making your notes. Now, as I did here, if we were to look at 100 such instances, I will do 100 calculations and then come back and look at. It took me what, 30 seconds, maybe 45 seconds to look at one instance, and then make my observation about whether it was right or wrong, and I made a note of it. Similarly, I will perform 100 transactions, or 100 calculations, or 100 instances of my feature if it were a non-transactional feature, and I will note down my observations. And by the end of those 100 observations and 100 pieces of notes, I will have a pretty good idea about how my AI feature works. I hope that helps.